Alright, I guess part 3 is necessary. um, so, the defenders just keep defending inaccuracies and explaining it wrong. Explaining it not even consistent with their own proclaimed proven truths and statements of their precise and always accurate and predictive science. And yet they can't consistently apply their own model. Alright, so first holiday. So it's not the entire region that is filtering by polarized mechanism. Of course it is. The region just gets smaller and smaller. It turtles all the way down until you get to the atomic element. And I even stated the neutron would probably be the smallest magnet. What's too complicated about that? No, nothing. But just a surface. That is your explanation. No, that's my explanation of how it works, in the sense that that's what you'll see happen. So if you want to understand it the simple way, I pointed out in the video, it's more complicated than this drawing. I said that in the video. It has to do with electrons and protons and the flow of the force between them. The capturing of force, all of that stuff. It's much more complicated than just little red boxes and little blue boxes, idiot. But for the sake of understanding, all you really need to understand as a model is that stuff going out one end gets filtered one color, stuff going out the other primarily gets filtered another color. And that makes it understandable. That's what happens. You can correlate those two things reliably. Jesus. But in the past you have said, in fact in your last video drawing you sketched it as an entire region. Well, yes, sometimes I'm just talking about a magnet. I'm not talking about breaking the magnet. Was there somewhere in there I was talking about breaking magnets? No. So what was the point of me showing the magnet as a bunch of little magnets inside of it? You don't think you think I got nothing but time on my hands, right? So every time I draw a magnet, I'm going to draw every electron inside the magnet? That might only take about 1,000,000 years. I mean, you're just such a putz. This is just such bullshit. You write a comment like this. Why didn't you show all the electrons and the protons in the magnet? Oh, I guess because I can't visually do that as a practical fact. Shit. Anyway, in fact, your last video drawing sketched the entire region. Yes, exactly. The opposite of the selective braking mechanism you now propose. No. Let's go back to the video I did about Ken Wheeler. On my message board, under the subject of magnetism, okay, you'll find this video and this drawing. And this is basically, you can think of this as the domains, or you can think of this as the little magnets of the atoms, or you can think of this as neutrons. It just doesn't matter. The point is a magnet is formed by aligning them in a off phase sequence. That's it. They're all aligned red, blue, red, blue. They just can't be all blues across and all reds across, or you don't have a magnet. So don't tell me what I have or haven't done. I mean, the fact that you can't get the general idea, that's your problem. Sorry. Because I've made it so much simpler than anything taught at MIT. Shit. Alright. Let's see. Posing the, selective braking mechanism we now propose. So like I said, I proposed in that video that I said the exact words. The atomic bonds are weaker than the nuclear bonds. That's what I said. They break at the atomic bonds. Whole magnets break apart, not half a magnet. You don't get to take a tripole or a zoptal pole or something like that. You don't get to make a multi-headed magnet. Alright, the entire region. The opposite of the selective braking mechanism you now propose. It seems also by your theory, I don't want to say that you can't have a tripole, so I don't want to, that's wrong. Because in a sense, that's what even maybe a helium atom does and some other atoms, is there's actually one south pole and two north poles. It's a magnet in two directions. But, you know, no need to, I'm just saying, just for clarity, I don't want to say it's not possible for there to be more than one, for a magnet to have more than one pole, more than two. It seems also by your theory the sides of the magnet shouldn't even be magnetic. Well, I don't know why they wouldn't be, because they're still filtering. But the point is obviously by my theory, magnets are created by alignment. So when the alignments are consistent, there's going to be more reflections back and forth and pressure, and therefore there can't be attraction. And when the opposite is true, the opposite will be true. The pressure will drain out. It won't be as strong. That's just a fact. That's not even the right way to say it again either. So I take that back. You can never get stronger than having poles facing each other. And the fact is that the strength of even that 50% is, when it's face to face, is going to be strong. Now you can get stronger if you bring the two magnets into each other this way. So the north end is heading to the south end of another magnet. That's going to be even stronger. But this is strong. Okay, it's... well, anyway, something like that. This is a detail I don't think that's terribly important in terms of going through the process of explaining the subtle differences about when you have, because it's two poles. Okay, obviously when you bring two magnets together this way, you're losing the strength of the other two poles attracting each other. So obviously that's different. But anyway, it's off the subject of what Professor Lewin explained wrong. So again, I don't know why you're bringing up these other elements of magnetism on this video. Why are you doing that? This video is about a specific point about magnetism, whether field lines are an actual thing that exists, that a magnet's producing, or whether it's just a reference that humans use in understanding the force of the magnet. Is it something real that the mechanism is producing, or is it just something contrived by humans doing measurements with instruments that can't measure it correctly? It's another one of those things. You can't measure the magnetic field without affecting the magnetic field. Like you can't measure gravity without affecting gravity. Just can't do it. It seems also by your theory, the sides of the magnet shouldn't even be magnetic. Well, as I stated, they would be. This is clearly wrong. Well, that's not what my theory says, so you're clearly wrong. I'll call your explanations technical when you give us the maths. So again, I should redo 100-year-old math. So if I just copy and paste Maxwell's equations, you're going to say, will you shut up? I'll just put my name on them. Is that what you want me to do? I mean, I'm pretty sure I could refine Maxwell's equations because he was an ether believer in her and he didn't really understand the concept. So the fact that he got any of it right might be, he might have extra bits in there that are unnecessary. Just as I think Einstein surely does. But the point is what is the math? The math is merely doing experiments, taking measurements, and contriving a formula to fit the results. So the math is basically saying, look, let's roll dice, and we'll do the math. And we'll figure out a formula for dice rolling. And we'll figure out how precise our dice are. And we'll say, okay, there's a certain amount of odds of snake eyes and a certain amount of odds for boxcars, and those odds are going to end up being the same by observation, and then we'll come up with a formula that dictates that probability. Now, have we done anything? Have we explained how the dice that happened? So if they come up with a theory that says angels push the dice by those probabilities, and then I argue, no, the real cause is they bounce off surfaces and get not randomized, they get altered in very physically precise ways by certain amounts of energy and impacts, and that is the cause of the probabilistic outcome. You don't understand the difference between those two things. The math doesn't change for either party. The person describing a different cause isn't obligated to create new math to create a different cause. for the effect. You can't understand that either. I mean, that's the undercurrent of the 7 years I've been doing this, or whatever it is now, 5 at least. And you still haven't caught on that I'm talking about them not doing experiment, not getting data wrong, although they have gotten some data wrong, as I'm pointing out with field lines. But the point is they have their theory of cause wrong. Shit. So some idiot, sharper plus pluster, sharp shooter maybe thinks he is. Oh yeah, you're real sharp. Yeah, your penis is probably sharp and thin and short. In case you haven't noticed, he's too dumb to do math. Well, that's just a brilliant retort. Wow. Amazing. Alright, so on to the mindless douchebag, who at least did point out in the previous video that I had pointed out that magnets just break in pieces, and the pieces are all turtles all the way down, magnets all the way down. But the truth is that you can't duplicate it with these magnets, because these magnets can never get as close to each other as atomic magnets. Anyway, they can never correct for the phase problem, where atomic magnets can. If I put a field going one way and I put another field going the other way, so again, these aren't going anywhere, so this is just, they're both fields of energy that are expelled by the magnet through the natural process. Everything's expelling energy, okay? The non-magnet, it's completely randomized blue and red. The magnet, it's either blue or it's red. How many times have I gone over that part? The net field does decrease. So again, he's saying the net field does decrease. It doesn't. So, sorry, there's more magnetic potential in that field. Any way you combine two magnets without merging them into each other, like clay or something, you're going to increase the magnetic field in terms of its total field if you measure it with a small enough compass. So if you have a small enough compass, a small enough dipole, and you stick it in that field, it'll always at all locations measure as strong or stronger than it was. You can't make the field weaker. So that's just wrong. From this, the other explanation does follow. So I don't agree with your premise. And they are both compatible. I don't know, there can't be any compatibility. He implied, if not directly stated in his video, that the nail falls not because the nail became less magnetic, but because the other magnets became weaker in their pulling force. Anything beyond this would be pointless semantics. It's not pointless semantics. I pointed out in the previous video, if you watch it, you actually watch it, I pointed out clearly that the only thing that makes the nail fall is the fact that it can't turn. If the nail was allowed to turn so it could maximize its potential, if the compass needle was allowed to move, it would feel the stronger magnetism. So if you create a Gauss meter and you don't allow the little bits inside there doing the measuring to move to align to the field, they'll incorrectly measure the field. The only way you can accurately measure the field is to allow the thing you're measuring with to orient to it. It has to orient to a field to measure the field. So, fuck you, this isn't semantics. And it's clearly not consistent with the underlying principle, which is virtual photons are what's creating the field. So the real core stuff that's actually creating the force carrier, the virtual photons, if you are obedient to their function, you'd understand that there's no decrease in the field. Alright, at 1435 you say that the field is traced out by compasses. But when you put the compasses together, the compasses themselves would repel each other. What I said was, yes, your test instrument doesn't work, okay, because it affects the thing you're testing. So it's a lousy test instrument. You can't really measure it if you're going to affect it through the measurement. Those kind of measurements are always thought of as invalid because you're not measuring it in its real state, you're measuring it in its disturbed state. And the compass needle, when you have a whole bunch of them, they disturb the state of the field. They increase it. Okay, this should be obvious. Well, he didn't make it obvious in the video. Again, he didn't even point out that the nail fell because it couldn't orient to the field. Let's see. Okay, this should be obvious. Those needles, at least at that setup, would repel each other for both the north and the south needle. Yes, of course, that's the whole point of the repulsion. The repulsion would be substantial, and they'd all be in phase rather than staggered, because there's no mechanism to force them to stagger. Jesus. And they can't, physically, because they're starting from one magnetic plane. Let's see, those needles, at least in that setup, look, it's like the ferrofluid on a magnet. When you see those little drips of ferrofluid that are shooting up. Now, what's really happening is, okay, they're all magnetizing and they're trying to stick to each other in a straight line. But what's happening is as they're doing that, they're all in phase with each other. So all the points, all the tips of all those little blobs of fluid are actually magnets north to north, south to south, and they're repelling each other. And so that's why they all start leaning towards the outside. They're not representing the actual field lines, they're representing bent lines by the measuring fluid. Shit. I've said that 3 times now. Alright. Would repel each other for both the north and the south needle. So the north needles would repel each other and on the top, but also the south needles would repel each other on the bottom. Yes, duh. So these effects, which are negligible to begin with, would cancel themselves out. This should be obvious. How would they cancel themselves out? I mean, did I draw a picture of that? Yeah, I know I did. I can't believe you said something this stupid. I mean, you know, here's the picture. So the needles are all lined up, south to south, north to north. So it's like, look, I'll just do it again, bigger. And I'll put the red in, you dumbass. There. They're all, the compass needles are magnets. Here's the magnets, a north-facing magnet. Here's the magnet. The compass needles, because of their connection to the surface, flat on the surface, they have to all be in phase. So let's put them all the way to the, let's let them connect all the way to the surface. And you'll get that, maybe you get it, I don't know, you still probably won't get it. You're such a dumbass. So that's the magnets. So let's even make them square. Maybe you get it then. You get it? If the magnets are sitting on top of the surface, they're going to repel each other on both these sides. That means they're going to be forcing each other this way. And clearly this end doesn't move as easily because it's stuck to the magnet. So this is the end that has to do all the moving. Everything's going to spread out here. Spread out, spread out. So you're going to change straight lines, well, those aren't very straight, into this bullshit. And this is bullshit. 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 It has nothing to do with what actually happens. The field lines are not bent, they're straight. Shit. It should be fucking obvious. Fucking cunt. Alright. At best, one could argue that the needles closer to the magnet repel each other more, maybe. And again, they can't though, because they're stuck to the magnet. The force pulling them towards the magnet, the strong magnet, versus the weak compass needles, is much stronger. The force between the big magnet and the red part of the compass needle is much stronger than the repelling force between the red and the red of the compass needles. They're small little magnets. The big magnet's force is much stronger. Shit. Maybe. But that would only mean that the lines they draw would bend completely the other way. How could they blend completely the other way? That would be crashing into each other. I don't know. It's just such a dumb comment. Maybe the field lines are more straight than depicted. So now he's conceding. Oh, well, yeah, he just drew them a little bit off in the crookedness. They're not substantially wrong. Well, let me draw what he drew again. I'll point out how it's fundamentally sloppy. It wasn't the key point of my video, but I mean, now that because he does it they all do it all the time. So, you know, they draw their magnet and they make their lines, and so this is exactly the kind of lines he drew. He drew two lines like this, and then he even filled it in with the interior lines. Alright? Which is really dumb, because yes, the ones out here, okay, you might have some slight, like this one here might start going, because it's gonna, like I said, the noise from this side can get to something once it starts this angle. See, it's straight lines again, so we have to understand it's all coming out straight lines. So obviously some of these lines are going to come out and they're going to go past this border of the edge. And once they go past the border of the edge, they're going to feel the influence of the red side, and that's going to make the compass needles turn. Alright? So yeah, there can be stuff that's going like this all the way over here. It just goes through this bare little corner over here. So it doesn't bend until it gets way the hell out here, and then it starts to bend. But these never bend, okay? The ones that are coming out the middle, no bending happens to these. I mean, you might play a game with something on the edges here, but the ones going through here, I mean, theoretically you could have a line that goes like this. Okay, so it ends up going through the middle. But, you know, we're talking about at least I'm talking about, if you're going to illustrate what's taking place, it's the dominant feature of the middle of the magnet is fundamentally straight, not bent. And again, even drawing it like that with any curved lines at all is just misrepresenting how these field lines are created, because it really should always be illustrated that these lines are being created by straight line force. It really should. Alright, anyway, but again, your comment has nothing to do with the fact that the thing that made the nail drop was the fact that it wasn't allowed to move, to maximize the stronger field, to take advantage of the stronger field. And because it was ferromagnetic, it was also unable to do that, and then to maximize its magnetism. So it was a compass needle forced to be in the wrong position, and if you do that to a compass needle, and you're using that needle to detect how strong the field is, you won't detect the strength of the field accurately. So if you force the needle to be in the wrong position, and then attempt to use it to measure like a Gauss meter, you won't get an accurate reading. Alright, but they should diverge, not in the technical sense, if you know what I mean. Well, they don't diverge in any sense of, okay, no, there's a minimum amount. Look, the magnets aren't perfect. So we're not even talking about a perfect magnet anyway. There's some red shit coming out of the black end. There's some black shit coming out of the red end. Obviously. We have never made a perfect magnet. So yes, there is some force that comes out angularly in the beginning, but it comes out as a harsh angle. It doesn't come out as a bent line. Alright, when you're far away enough. So again, yeah, well again, we're not, the thing creating the magnetism is the radiation. So I'm just saying that's where the focus should be. What's the radiation doing? The radiation's moving in straight lines, not crooked lines. And I'm just saying when you represent a magnet by averages of what a compass needle does in that position, especially averages that are based on what compass needles do when you have a whole bunch of compass needles interfering with each other, then you're going to get a wrong impression about what the actual field is. Because you don't have any way to measure the actual field, because anything you use to measure the field is going to interrupt the field by creating another field. It's, you know, yeah. So again, you haven't countered my argument, which is he clearly indicated that was the diminishment in the field, and it wasn't. The field didn't get weaker, the magnet that was the nail got weaker. If you used a regular permanent magnet, it wouldn't have fallen. If the nail was a permanent magnet, it wouldn't have fallen. Well, yes. It would, not unless you, it still wouldn't have. Because as you move the wrench closer, it would have just pushed it a little further, but the north side would still be strong enough to hold it up. And if you pushed it past the magnet, it would end up sticking to the wrench. It would fall, but it would move into the wrench. And that's the problem. He makes such accurate statements. So this is the stupid sharpener guy, so we're done with sharpshooter. And that's the problem. He makes such accurate statements that completely fail when you scratch just a little bit. So again, where did you scratch any bit? I'm arguing the same exact arguments and pointing out how what you're saying still isn't correct. And still has nothing to do with what was wrong with the Professor Lewin's video. His arrogance is only thing keeping his head in his ass. Whatever. When in reality he's dumb as a box of rocks. Right. Well, look, you know, the future will tell the tale, asshole. And I'm quite confident who's the rockhead and who's going to be on the ash heap of stupid motherfucking cunt on Earth. Waste of space, waste of lungs. They should use you for your organs, because nobody's worse than you, right? So they could just give your organs to a mass murderer, and they've probably done a good job. You couldn't have, you're just a stupid piece of nothing shit. A shit-talking, weaselly little, you know, ballless, throwing stones from behind your little rocks and then calling yourselves a sharpshooter. You're a fucking coward. So, enough of that. So what else did I want to say? I did want to add a little bit about the neutrons, because that is kind of an interesting subject. Because the temperature thing always gets into this, you know, with magnetism. And I think part of that temperature thing just is the fact of whether something's turning, moving. So more than just doing this and this, it actually might be spinning. I think that happens with neutrons. And that's why we don't see their magnetism. So if you take a regular magnet and you spin it really fast, nothing could detect the field, because the field would constantly reverse. So it would be the same thing as making it a random field. So it would seem like it had no charge, even though it had a dipole charge. So dipoles can be made invisible by spinning them. And so I just point that out. Alright, so enough. Yeah.